Okay, pre-cal, here are your examples for finding vertical and horizontal asymptotes. We are first going to find the domain, find the asymptotes, and then we're going to find the x and y intercepts. You may be asking yourself, why are we doing all this? Well, because guess what's coming? We're going to be graphing these. I know you're very excited. Try to calm down. Okay, so let's figure all this out. The first thing I'm going to do is factor anything that can be factored. Of course, that is my very first step all the time. So my denominator here will factor because it's a difference of squares. So once I do that, now I'm going to go ahead and define my domain. I'm always going to do that first. So x can't be -1 or +1. Okay, so there I'm going to define my domain that way. Now what I'm going to do is jump right in with my vertical asymptote. And of course, my vertical asymptote occurs at those restricted values. We have 2 of them. And then my horizontal asymptote, I have to look at the degree of my numerator and denominator. Well, the degree in the numerator is 2 and the degree in the denominator is 2. So if you'll recall from the other video, my rule when the numerator degree is equal to the denominator, I have a horizontal asymptote at y equals the ratio of the leading coefficient. So this leading coefficient is 2, this one is 1, so I have a horizontal asymptote at 2/1 or 2. All right, let's look at our x-intercept. To find the x-intercept, remember that is when y equals 0. Okay, so when y equals 0, essentially what you're going to do is set the numerator equal to 0 and solve. That's all you have to do. The denominator has nothing to do with it because you end up cross-multiplying and it turns to 0 anyway. So we end up with 0 equals x squared, and of course x equals 0. So my x-intercept is 0, 0. Remember your y-intercept is when x equals 0. And that is going to be y equals 2 times 0 squared over 0 squared minus 1, which is 0 over -1, which is 0. So your y-intercept is 0, 0. That should make perfect sense to you. When one of them is 0, 0, so is the other one. Go figure. All right. So number 2, my next problem, I am going to factor again. I'm always going to start with that. Beautiful. All right, once we factor, now we're going to go ahead and define our domain, all of x, such that x can't be 3 or -2. Just like that. Now we can reduce. If you'll notice, the x minus 2, or the x plus 2 and the x plus 2 go away. So my function now is x minus 1 over x minus 3. All of the rest of our information we get from there. And this will make sense when we finish up the notes at the end. Just trust me. Okay, so once we get that done, now I can define my vertical asymptote at x equals 3. My horizontal asymptote, let's look at the degree. The degree is 2 here and 2 here, lead coefficient 1, lead coefficient 1. So y equals 1. The x-intercept, I set the numerator, which is x minus 1, equal to 0. And I get 1, 0 as the y-intercept, or I'm sorry, the x-intercept. The y-intercept is when x is 0. So y equals 1/3. 0, 1/3 is my y-intercept. Magic. Okay, last example here. I'm going to, I know this is a big surprise here. We're going to factor. Everybody loves to factor. Okay, so again, domain restrictions are the very first thing. X can't be -4 or 2. All right, vertical asymptote is going to occur at x equals -4 and x equals 2. The horizontal asymptote, we have to look at our degree. This time, the degree in the numerator is 1 and the degree in the denominator is 2. That means that I'm going to have to pay attention to this one right here. If the numerator degree is less than the denominator degree, I have a horizontal asymptote at y equals 0. Okay, my x-intercept, set the numerator equal to 0. So there's my x-intercept, my y-intercept. Y is going to be equal to 0 minus 1 over 0 squared plus 2 times 0 minus 8. So it is essentially -1 over -8, which is +1/8. So there's my y-intercept. Very nice. In the next video, we're going to talk about slant asymptotes. They're really fun.